A lever is one of the 6 simple machines. Levers are probably the most common simple machines.
Made of a rigid bar that pivots around a fixed point, levers are used in everyday life. A lever consists of a load, or a resisting force, an effort, aka the applied force, and lastly, the fulcrum, which is the pivot point.
Levers are used to increase the force and to change the direction of motion. The word lever originates from the French phrase to lift.
Lever. Levers help you lift things that you couldn't lift with your bare hands. From ancient times
to modern day,
levers have been used.
The first class lever is the one you may most be familiar with. The fulcrum is in between the load and the effort. The closer it is to the load, the more force is applied, and this is called the mechanical advantage. From boat oars to bicycle brakes, first-class levers can be found anywhere.
A teapot is a unique form of a first-class lever. The effort, the fulcrum, and the load is the lid.
A spoon and a bowl together is also an example of a Class 1 lever. The fulcrum is where the rim of the bowl and the middle of the spoon meet. The load is where your food would be, and the effort is you pushing down on the top of the spoon.
The final and most frequent example of a first-class lever is, drumroll please, a seesaw. As you can see, the fulcrum is in the middle, and the load and effort are on either sides. In all second-class levers, the load is placed in the middle. Then the fulcrum and the effort are on opposite ends. They make the load move in the same direction as the force you apply. How close the load is to the fulcrum determines how much your force will be multiplied. The closer the fulcrum is to the load, the easier it will be to lift heavy objects.
A swing set is an example of a second-class lever. The fulcrum is where the top of both chains connect to the pole. The person's upper body is the load, and their legs are the effort.
A gate lock includes the effort, which is where you hold it, the fulcrum, where the hinges are, and finally, the load is in the middle.
The cattail game, found at Union Square Park, is a very uncommon type of second-class lever. The very bottom is the fulcrum, the person's feet are the load, and the effort is their arms.
The one second-class lever that can be found in any house is a door. As illustrated, the doorknob is where the effort is applied, the hinges are the fulcrum, and the door itself is the load. The third-class lever is very strange because no matter where you apply the force, the effort won't be multiplied. This means that the third-class lever does not have a mechanical advantage. This type of lever has the effort in the middle.
Using this lever will require more force than if you lifted the load vertically. The reason we use this kind of lever at all is because it does not change the direction of force, and the fact that we apply the force between the load and the fulcrum. This makes the third-class lever convenient.
Tongs are also third-class levers. The fulcrum is the point where the two arms meet. The effort is where you push. And the load is the object it is holding.
Chopsticks are a very unique version of a third-class lever. As you can see, the fulcrum is the finger in between the chopsticks. The effort is your finger pushing down on the top chopstick, and again, the load is the food that they are holding.
Like the tongs on a stapler, the fulcrum is where both arms meet. The effort is where you push, in the middle, and the load is on the other end. This makes a stapler a third-class lever. From ancient times
To modern day.
the levers have